तो उसमें देख लेते चलो उधर ही चलते हैं. I will go and maybe उधर ही देख लेता हूँ.
Good morning.
Good morning, sir.
Good morning, sir.
Good morning. I think others have not received the message. Okay, they are joining one. So let us start then at 10:55. It would be better. They didn't get the message. Okay. So, am I audible?
Yes, sir.
Yes, sir.
Okay. Next topic. Since this topic we have seen the Grubbler's criteria for plane mechanisms. Now let us move to the next one. That is, what do you mean by inversion of mechanism? Okay. We have seen the kinematic chain. What is it? Then a mechanism which is obtained from a kinematic chain by fixing one of the links of the kinematic chain. Okay, now let us go for the definition of inversion. So as you know that you can obtain a mechanism, okay, by fixing any one link. Okay, you fix any one link, you will get one mechanism. So in this way, by fixing different links, okay, at different times, okay, we can get as many mechanisms as number of links are there in the kinematic chain, right? And all these mechanisms which are obtained from the same kinematic chain, okay, by fixing different links, okay, these all are known as the inversions of the mechanism or inversions of the kinematic chain or inversions of the original mechanism. Okay, so for example, suppose it is your one kinematic chain that four rods are there like this, they are connected together. Okay, and the connection between two rod say by a pin joint or a turning joint. A turning joint is one which allows the turning motion between the two links of a kinematic pair. Okay, so here I have a choice. I have a choice to fix the any of these four links. Okay, so links are here one, here is second, third, and this one is 4. So I can fix anyone at one time. So say if I will fix link 1 or say if I fix link 2, so I will uh, join this link with some stationary part, maybe a ground surface, maybe a wall, okay, with the help of say nut and bolt. So this link is fixed. So whatever now I will get a mechanism. Suppose instead of fixing second link, okay, if I decide to fix the link 3, then again I will get a mechanism, okay, which will be very different, which will be looking very different from the mechanism which we obtained by fixing the second link. Okay, so in this way there are 4 possible combinations, okay, and you will get different mechanisms which will be useful for different applications. Okay, what you have to do, you have to study that if I fix a particular link, okay, and after fixing one link, if I make any other link as input link which is connected to the fixed link, so to fix link 1 and link 3 is connected, right? So I can make any one of these link as input link. So I will give some input to the link 3. Then you have to observe that how is the motion of link 1 and link 4. Okay, and by observing this motion, you will come to know the specific features of that particular mechanism and accordingly you can employ this mechanism in your applications. Okay, so I think that concept of inversion is now clear to you. Okay, so we will see what are the basic kinematic chains, and by fixing different links of that basic kinematic chain, how we get the different mechanisms. Okay. Okay. So this slide I just explained. Next, see the most important, or you can say that most basic kinematic chains are those which consist of 4 lower pairs. Okay, means there are no higher pair. Higher pair is, the example is KAM and follower. Okay, where there is the higher joint, H joint, between two elements, and out of these 4 lower pairs, the each pair being a sliding pair or a turning pair. Okay, suppose even if your pair is a lower pair, it should not be a screw pair. Okay, because what is important is here, in these 4 pairs there should be either a sliding pair or a turning pair, then they become very useful. Okay, so these are the important basic kinematic chain, 4 bar chain or quadric cycle chain, of which I have given the example in previous slide, right? That how you connect the 4 bars, 4 rods, okay, with each other and obtain the 4 bar chain. Then there is the next single slider crank chain. Okay, so in this what happens, there is one slider also. Okay, there are not all the 4 links are your rods or bars. There are 3 bars, 3 rods you can say, and you can give any shape to these rods. So one rod you can give the shape of a crank, one rod you can give the shape of the connecting rod. Okay, then one rod you can give the shape of the cylinder, etc. And one is there slider, means that link will slide with respect to another link. Okay, we will see that. And there is another basic kinematic chain, that is double slider crank chain. So in this particular kinematic chain, there are 2 elements which are sliding with respect to other links. Okay, and all these kinematic chains, okay, give the many inversions of the mechanism which are used in different applications. Okay, so let us first start with the 4 bar chain. It is very basic. The most basic kinematic chain of these 3 is the first one, kinematic chain with 4 bars. Okay, 4 turning elements or turning pairs. See here. So let us start with first. We will first cover the 4 bar chain and the inversions of 4 bar chain. Okay, so you know that in a 4 bar chain there are 4 rods. Okay, 4 links, 1, 2, 3, and 4. Okay, all the kinematic pairs are here turning pairs. So the motion between link 1 and link 4 will be of turning type. Then the motion between link 3 and link 4 will also be of turning type. Okay, turning pairs are there. All the 4 pairs are turning pairs. Okay. Now, depending on the moment of any link, okay, they have been named. Okay, for example, here if you see the link 4 here, this link 4 can turn, okay, completely. Link 4 can turn completely through 360-degree, okay, through one revolution. So such a link which makes a complete revolution is called as crank. Okay, then you take the notice of link 2. Okay, this when this crank will turn completely, this link 2 will only oscillate. Okay, it will only oscillate between these extreme positions. So say it is one position and this one is the second position. So link 2 will oscillate between these 2 points only. So this link 2 is known as oscillating link, okay, or rocker or follower, because link 2, most of time link 2 is the output link. So link 2 is known as follower, rocker, oscillating link, or lever. It is also known as lever. Okay, then what is the role of link 3? Link 3 transmits the motion from say crank to the lever. So link 3 is known as connecting rod or coupler. Okay, so these names are given to these elements. Now there is one law which is known as Grashoff's law. Okay, when this law is satisfied, then it is possible that any one link will make a complete rotation, or there will be continuous relative motion between two links. Okay, if this law is satisfied, this law is with respect to the lengths of the different links in the 4 bar. So what it says, Grashoff's law, that the sum of the shortest and longest link lengths should not be greater than the sum of the remaining two link lengths if there has to be continuous relative motion between the two links. If you want a continuous relative motion between the two links, then you should ensure this condition. Okay, so here say there are 4 links, and let us say that link 4 is the shortest. Got it? Say your link 4 is the shortest link, it is shortest in length, and say link 3 is the longest link. Okay, so what Grashoff's law says, that the length of the shortest link, L4 or LS, whatever you want to denote, plus the length of the longest link, L3, it cannot be greater, right? It cannot be greater means it must always be less than or equal to remaining two link lengths. So what are remaining lengths? What is remaining is L1 plus L2. These conditions should be satisfied in the mechanism. If this condition is not satisfied with respect to dimensions, with respect to length of the link, then the continuous motion is not possible. Okay, you will find that link AD, though you can rotate it, but it will not rotate through 360-degree. Somewhere it will get stuck because of the disproportions lengths of the links. Okay, understood this law?
Yes, sir.
Okay, so depending on which link you fix either the shortest link, you fix longest link, or you fix any other link, okay, L1 plus L2, you get different mechanisms. Okay, let us see those mechanisms. Okay, so depending on which link you fix, okay, you get different mechanisms. Those are called as inversions. So inversions of 4-bar chain are, first inversion is crank and lever mechanism, okay, which is used in beam engine. So what is a crank and lever mechanism? Here one link will be crank. You know, the property of crank is that the crank makes a complete revolution, okay. And what is the lever? Lever will only oscillate, it will only make the angular movement between two positions, okay. So one link is crank, another is lever, okay. This mechanism is used in beam engine, okay. So see here, frame is the link one which you have fixed, okay. So this frame may be your uh, one of the remaining two link lengths, okay. So that is fixed, then it is crank, shortest link, or you can say that the link which makes complete revolution, it is link 2. This link 2 will rotate, it will turn, okay, and its rotation will be transmitted to the link 4, which is lever, okay, through link 3. This lever, okay, this lever will oscillate. This lever will oscillate like this about point D. It will oscillate like this, okay, and it is pivoted at point D. Point D is pivoted on the frame only because ये जो structure है, this structure is meeting with the fixed link, okay. So it is the part of the structure. This link is pivoted here, okay. So these are the 4 links, and in order to use the oscillating motion of the lever, okay, we have added further links, like this piston rod is added here, okay, to which piston is connected, and this piston will reciprocate in the cylinder, okay. So here when it will oscillate like this, okay, so this piston rod, it will reciprocate in the cylinder, and then you can use this motion as a pump in order to, it was this beam engine is used in oil wells where you used to extract the oil, okay. So that is the example of beam engine. I will also show you the animation, okay. Next one is the coupling rod of a locomotive. So what is it? See, it is a coupling rod of a locomotive. Link 1 is this, that is the distance between two wheels. It is fixed, okay. Then to at point A, link 4 is connected. It is your crank, and at point B, link 2 is connected. And this link 2 and link 4 are connected by another link, which is called as coupling rod, okay. So what will happen here, as it is a special case, okay, where link AD is equal to link BC, both are parallel, link 1 and link 3 are parallel, that's why they are also equal in length, okay. So what will happen when the link AD will turn with a complete revolution, at the same time link CB will also turn, okay. Means here there are two links which are making complete revolution. Okay, so it is called as double crank mechanism. Double crank mechanism. Okay, there are other configurations also possible when you take the different lengths. So like you provide different length to AD and different length to link BC. Then also it is possible that they both will make a complete revolution. So if in a 4-bar mechanism, two links are making complete rotation, then we will say that it is a double crank mechanism. There is double crank. Okay. And the third one is your Watt's indicator mechanism. It is your uh, double lever mechanism. In this, there are 4 bars, 4-bar chain it is. Okay, but no link in this particular mechanism makes a complete rotation. Only the links oscillate between 2 points. Okay, that's why it is called as a double lever mechanism. Double lever mechanism. There is no any crank. And looking at the setup, you will say that it is a setup of 4-bar chain. Okay, so link 1 is your fixed link. Link 2 is your this link which is AC. Then link 3 is your CE, and this link BFD is considered as one link, link 4. Now in order to use the motion of this, the point F is connected to again a indicator plunger. Where this mechanism is used, Watt's indicator mechanism, it is used to measure the pressure inside the cylinder. Okay, so it may be a steam engine, so a high pressure steam will enter here. Okay, and as it will enter, okay, it will push the piston upward. Because of that, point F will go upward, and the point E will copy the motion of point F. Okay, a similar mechanism is also there, that which is called as pantograph. Okay, where we will prove it that the the point E will copy the path of F, as point F is moving in a straight line. Okay, the point V will also move in the straight line, and the motion of point A, movement of the point E from E to E dash, it is depending on what is the pressure inside the cylinder. Okay, so with the help of this motion, you will come to know what is the pressure. Okay, if you attach some scale here, suppose if you attach some pressure scale here like this, you mark different pressure values like this, so you can read you can sorry you can read what is the pressure value from this pointer. This here you can attach some pointer, it will point to the particular marking from where you can read the pressure. Okay, so Watt's indicator is also an inversion of the 4-bar chain. Okay, and it is which inversion? It is a double lever inversion. Okay, so I am showing you some videos. So let us see the beam engine ka video. See how it was here. Crank is there. Crank will be connected to your some power source, right? It may be an electric motor. Okay. So it will turn here, its motion will be transmitted to the lever, lever will oscillate here, and its oscillatory motion will be transmitted to the piston, where it will perform the
Are you operating meter or do you see the PPT?
you are not clear through. Can you please repeat the question?
Sir, are you showing some video because we the PPT?
Am I clear to you?
Yes, sir. But are you showing some video? Because we are still able to see the PPT only.
Okay, okay, yes, okay. So it has gone to some other window, okay. So it is not showing it. Okay, yes. So let me stop share then. I will show you the, where is that? Just a second. Now, can you see the video?
Yes, sir.
Okay. So see, this is the beam engine, which is used to extract the oil from the oil well. Your 4 bars are here. This is frame. This one is frame. It is a crank. Just uh, do not confuse with the shape of the crank. Okay. Here, shape of the crank is in form of pulley. Then it is your connecting rod, coupling rod, and it is lever, which is oscillating. So we are using its oscillatory motion in order to extract the oil well. Okay, with the help of additional links. Here there is one crank and one lever. So it is a crank lever mechanism. Next, I will show you double crank mechanism. Is it visible to you, the video?
No, sir.
No. Okay, so
Sir, it is the folder is visible.
only folder is visible, right? So I will first open it and then share it. Okay. Okay, this is the video double crank mechanism. Okay, one double crank mechanism we have seen in locomotives. Okay, in steam engines, we used to connect the two front wheels and back wheels of the engine together, so that traction is improved between the wheels between and the track. Okay, it is another example of double crank mechanism where the crank size is different. Okay, crank size is different. See, This is one link which is making complete rotation, this one. So it is one crank. Second one is this one. This one is also making a complete rotation. So it is an example of a double crank mechanism with different crank sizes. Then I will show you the different one. Okay. So it is a double rocker mechanism, you see. Okay. Both of these links, this red and green, they are just oscillating in their path. See, from here to here, and red one is on this arc. Its path is on this arc. So complete rotation is not possible of this. As both the links are just oscillating, it is called as double lever mechanism. Okay, and again it is a function of which link of the 4-bar chain you are fixing and what are the whether Grashoff's law is satisfied or not. Okay. Now again let us go back to the slides. Okay, if we run out of time, join back immediately.
It's not like that, but you should tell me, no, sir, you are giving me anybody else without my knowledge also how it is.
Okay, so we have seen these three different inversions of the 4-bar chain. Though mechanism are so complex, so huge, so heavy, or so small, but they are all derived from the same 4-bar chain. They are just the inversion. Okay, and depending on application, we give the size to the mechanism. Next, kinematic chain is your single slider crank chain. Okay, so here what it consists of, there are 4. Any question? Saurabh? Saurabh? Okay. So there is single slider crank chain. In this, there are one sliding pair. Okay. So here, see, it is connected like this. It is a frame. It is a frame. Frame 1. To frame, this crank is connected. Second. And then there is third link, which is called as connecting rod. And this connecting rod is connected to the piston icing. Okay, so such a mechanism you will find in ice engine. Okay, so what is the difference here? Here is difference is that there are 3 turning pairs and 1 sliding pair. Okay, let me just draw it a little bit. So if I draw the complete cylinder, like this, so it is your cylinder, and cylinder can take any shape depending on requirement of the application. Okay, so now it is up to you that which link you are fixing. Okay, and according to the link which is fixed, you will get a different mechanism. For example, in this particular case, let us fix the cylinder. Okay, so if cylinder is fixed, this is also the part of frame, cylinder is also the part of frame, and you try to give the motion to one link which is connected to the fixed link. Okay, so either you can give the motion to link 2 or link 4. So suppose what kind of motion we can give to the link 2, that is turning motion. Okay, so if you turn link 2 like this, okay, what will happen? Its turning motion will be converted to the reciprocating motion of the piston here. This piston will reciprocate in the cylinder. Okay, and as you have fixed one kind link of the kinematic chain, okay, this has become a mechanism which is called as an IC engine mechanism. Okay, then secondly,